Welcome everyone, and this is Science with Jackson. Today I'll be explaining problem 3 of exam 2. The problem setup is that we have a bulletin board, so demonstrated here, on a particularly windy day, hence the fan. Wind. Turbulence flow. So in the first part, we are trying to find the drag force acting upon the bulletin board, the advertisement right here. Trying to find the drag force on this lovely Kool-Aid advertisement. Kool-Aid, fruit punch best. So, as you can see here, to find the drag force on the bulletin board, we have to know this little equation. The force of drag goes to 1 over 2 c the coefficient of the drag times the velocity squared of the wind times the density times the area. So first we have to know what our area is. The bulletin board, the wind is acting on this surface of the bulletin board, so this is the area we're looking for. We know the velocity of the wind, and we are given the density of the bulletin board. So all we have to do is know the coefficient of the drag force that is acting on the bulletin board. We're giving a few sets, and I have to choose from one of them. And because this is a vertical flat plate, so the coefficient of the pressure the coefficient of the pressure overcomes the coefficient of the friction. So our coefficient of drag will most likely equal to the coefficient of the pressure. We are given all of the variables. We plug in and we note the force of the drag. In the second part of the problem, we are trying to find the drag force on the flat plate. However, unfortunately, as you may see, this piece of bars representing the flat plate is not quite flat. We'll still continue on. So in this problem here is most the same, but we still have to know what our area is. In a flat plate, the coefficient of the streamline alongside the flat plate overcomes the coefficient of the pressure acting on here. If it was a flat plate, which is not. In which case, the coefficient of friction will overcome the coefficient of the pressure, making the coefficient of drag mostly equal to the coefficient of friction. And as we can see, assuming the wind is coming along, is streamlining here, in a flat plate, it will mostly go around streamline here and here, so the coefficient of pressure, that is why the coefficient of pressure nearly equals to 0. And over here, because it is flat along this plane and it's coming over here, it's acting on a very little area, so we assume that the coefficient of the pressure, coefficient of friction will equal to 0. And on the third problem, we're trying to find out in what ways we can lower the drag force acting on the bulletin board. And I suggested several things. One is decrease the area of the bulletin board. That way, the wind is acting on less area, making it slower. Or if we place an object over here, in that case, all the wind will be going past the bulletin board. And as a special treat, meet my good friend, Mr. Hearn. And he'll be demonstrating what happened to the bulletin board if the drag force is much more than what the object can take. So Steven, please stand here. We'll turn up the fan.
You're blowing me away! With science!
With science! And here henceforth, Science with Jackson. Thank you very much.